Araw-araw tayong bumabiyahe papasok ng opisina, di ba? Pero napansin nyo ba, kahit pareho naman yung ruta mo, hindi laging pareho yung travel time mo. Minsan, sakto lang na 1 oras. Minsan, ang bilis. Tapos, minsan, inabot ka na ng matinding traffic. That is the reality of our daily commute dito sa Metro Manila, or kahit pa sa mga probinsya. So, the big question for us problem solvers is, bakit nga ba nag-iiba-iba to araw-araw?
Bakit nga ba nag-iiba-iba? Same route, same mode of transportation, tapos same time ka naman umalis ng bahay. Well, ang tawag natin dyan is natural random variation. Kahit gawin mo yung exact same process araw-araw, there will always be slight differences. Ganyan din exactly yung nangyayari sa operations natin sa trabaho. For example, sa isang BPO setting, kapag sumasagot ka ng customer calls, it can't always be exactly 3 minutes per call, di ba? O kaya sa logistics, kapag nagde-deliver ng parcels yung mga riders natin, hindi pare-parehong bilis ng biyahe kasi may traffic, pabago-bago ang weather, o minsan may delay pa lang doon sa warehouse. The point is, every single repetition of a process is just a little bit different. Nagva-vary talaga siya. Para mas ma-visualize natin kung paano nagmamanifest itong variation na to sa operations, let's put some numbers dun sa araw-araw mong biyahe. Let's say, on average, yung travel time mo takes about 60 minutes. Ito yung tinatawag nating mean. Pero minsan, kapag holiday o walang pasok ang mga estudyante, you hit your shortest day na umaabot lang ng 45 minutes. On the flip side, kapag umuulan tapos may aksidente sa daan, you hit your longest day, which can take as long as 75 minutes. Now imagine plotting your daily commute on a blank chart. Every single day is one dot. Kung mapapansin mo, the dots will start to pile up vertically doon sa middle, around our 60-minute mark, simply because yun ang pinakamadalas mangyari. Tapos, pakonti ng pakonti yung dots as you move outward, trailing off at the 45-minute and 75-minute extremes. This behavior, kung saan nagkukumpulan sa gitna yung data points, is perfectly natural. And kapag tiningnan natin yung hugis na nabuo ng mga dots na to, that leads us directly to one of the most famous concepts in statistics.
Notice how this natural, random variation forms what we call a symmetrical, bell-shaped curve. Ito yung tinatawag nating normal curve or normal distribution. Kung natatandaan nyo pa nung school days yung grading on a curve, eksaktong ito rin yun. The bell shape is literally the universal footprint of random variation. Centered at the mean yung pinakamataas na part ng bell, which is our 60-minute average, tapos pababa ng pababa yung curve, trailing off towards the extreme ends. Sa pag-aaral natin ng mga proseso, you will always encounter this shape because almost every natural process in your workplace will form this exact curve kapag nagplot ka ng enough data points. Ngayon, paano natin susukatin yung spread ng curve na to nang hindi sumasakit ang ulo natin sa math?
Para sa ating mga yellow belts na nagsisimula pa lang sa data analysis, let's keep the math very, very simple. Ang lawak o spread ng bell curve mo is measured by what we call standard deviation. So paano ba ito kinocompute? In practical terms, gamit yung commute example natin. First step, find the range from your mean to your extreme. From the 60-minute mean hanggang sa 75-minute maximum natin, that's a difference of exactly 15 minutes. Same thing applies going down to the 45-minute minimum. It's also a 15-minute difference. Second step, the normal curve tells us that the edge of the bell usually trails off at a distance of exactly 3 standard deviations. So you just simply divide that 15 minutes by 3. And step 3, our result is 5 minutes. That means one standard deviation in your daily commute is exactly 5 minutes. Diba? No need for complex calculators, ganun lang siya kasimple visualize. At ngayong alam na natin na 5 minutes ang isang standard deviation mo, gagamitin natin ito para i-predict ang future.
Dito na papasok yung power ng inatawag nating empirical rule or yung 68, 95, 99.7 rule. Always remember, these percentages are universally true for all normal curves. Let me translate this into practical predictability para sa araw-araw mong biyahe. Plus or minus 1 standard deviation, meaning 60 minus 5 and 60 plus 5, is 55 to 65 minutes. Sinasabi ng rule na around 68% of the time, nandyan lang ang itatagal ng travel time mo. If we widen our view to 2 standard deviations, meaning plus or minus 10 minutes from the mean, 50 to 70 minutes ang magiging biyahe mo approximately 95% of the time. And finally, 3 standard deviations covers 99.7% of the variation, spanning from our shortest day of 45 minutes to our longest day of 75 minutes. By mapping this out, eksaktong alam mo na kung ano ang probability na magiging travel time mo sa kahit anong araw. You're no longer guessing, you're actively predicting your process. At ang level of predictability na ito ang eksaktong dahilan kung bakit kailangan natin itong i-apply sa mismong trabaho natin.
Kaya natin pinag-aaralan at hinihimay ang normal curve is because it is the ultimate tool to depict random variation in our processes. As you dive deeper into your Lean Six Sigma journey, ito ang pinakagagamitin nyo to measure process capability and drive operational control. Isipin mo na lang, sa operations ng isang fast food chain like Jollibee, o kaya sa bilis ng pag-process ng mga lisensya sa LTO, o kahit sa pag-handle at pag-resolve ng tickets sa mga BPO natin. Kung naiintindihan mo yung normal curve ng mga mismong proseso nyo, alam mo na agad kung kailan normal lang ang delay at kung kailan may kakaibang nangyayari o special cause na kailangan mong solusyonan agad. Mastering the normal curve is exactly how we identify and control the chaos in real-life Filipino workplace processes. Ang tanong ngayon, kung hindi mo kayang sukatin ang variation sa pang-araw-araw na trabaho mo, paano mo masasabing kontrolado mo talaga ang resulta ng proseso mo?